this computer. Okay. So now we are looking at question 1 of this funnel. And let's take screenshot first. Yes. Okay. I think first thing is to mark the coordinates. So we can take 1 as origin, 0, 0. Number 2 is 5, 0. Number 3 is 10, 0. Number 4 is 22, 0. Number 5, 27, 0. Number 6, 32, 0, right? Then number 7, uh, okay, this is 8. So each one is 2. Each one is 2 meter. So number 7 is what is X? Yeah, this is at 8 at 4 meter. So 1, 2, 3, 4, 7, 8. 8 at 4 meter, 32 meters. So number 7 is X is 4, Y is 2. X is 8, Y is 4. X is 12, Y is 6. X is 16, Y is 8. X is 20, Y is 6. X is 24, Y is 4. X is 28, Y is 2. Okay. Then number 14, X is 12. No, sorry. Yeah, number 14. Y is 4. X is um, yeah, we Yeah, we need to check it. So for 14, we can check this length. Now this distance and this distance we know, so we can find this length. Let's do a distance formula, square root of x2 minus x1 whole square, y2 minus y1 whole square. Calculator. Meanwhile, let's set MATLAB up. Okay. So this distance is 4, comma 2, 5, comma 0. So 1 square plus 2 square, root 5. This distance is root 5, and that distance 8 and 4, 4 and 2. 2 root 5. So this distance is 5 plus 20, so 5. This distance is 5. This length is 5. 5 meter. So this length is also um, so, not necessary. We can get from angle. Okay. So this length is same 2 root 5, and this angle and this angle are same. So this angle is 2 root 5. This is 5. This is root 5. Okay. So this angle we know. So we know this angle. So this is hypotenuse and this is adjacent. This is adjacent. This is hypotenuse. So this length has to be 5. Okay. So this one is 13, comma 4. Okay. 13, comma 4. And this one is should be symmetrical. So from here it is 16, so 3, so this is 19, comma 4. Okay. So we have all of the coordinates of all of the nodes, and now we can create the, you can go to any of the, you can go to any of the truss MATLAB code. If you remember, uh, Amira, you can use the latest one. I must have sent. Oh, 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 just a second. Okay, can you both stay on here? I will be back in the Zoom. I need to inform someone in another Zoom. Oh, but we can't. We are recording. Uh, Okay.
Okay.
No. Let's finish it. Let's finish it. So you can check in my sent. Just a second. Oh, mm, okay. Yeah, there. Do you remember, Mira? This was I sent after the. This was for trust, this folder. So you can go to this folder and let me open something from there. Okay, take any problem, that's fine, whichever one. Take this plain truss. And you can copy it and save it. Mhm. Just give me 1 second. So, so let's put in all of the coordinates now. So these are the coordinates, right? So now joint coordinates are in meters. Joint 1 is 0, 0. Joint 2 is 5, 0. Joint 3 is 10, 0. Joint 4 is 22 0, join 5, 27 0, join 6, 32 0, join 7, 4 2, join 8, 8 4, join 9, 12 6, join 10, 16 8, joined 11 26, joined 12 24 4, joined 13 28 2, joined 14 13 4, joined 15 19 4. That's all. Okay. Then your connectivity, that's very important now. So we will give names to the truss elements. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay. So totally 24 members. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, I think I missed one. I missed one. Okay. 13 is this one. 14, 15, 16, 17, 18, 19, just a second. three, 1, 2, 3, 4, 5, 26. Let's check now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay, 26, right? Let's make sure again. 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Yeah, 26. Okay. So now let's put in the connectivity. So member 1 is connecting 1 and 2. Member 2 is connecting 2 and 3. Member 3 is connecting 4 and 5. Member 4 is connecting 5 and 6. Member 5 is connecting 1 and 7. Member 6 is connecting 7 and 8. Number 7, 8 and 9. Number 8, 9 and 10. Number 9 is connecting 10 and 11. Number 10, 11 and 12. Number 11, 12 and 13. Number 12, 13 and 6. Number 13, 7 and 2. Number 14, 2 and 8. Number 15, 8 and 3. Number 16, 3 and 14. Number 17, 8 and 14. Number 18, 9 and 14. Number 19, 14 and 10. Number 20, 10 and 15. Number 21, 11 and 15. Number 22, 15 and 12. Number 23, 15 and 4. Number 24, 12 and 4. Number 25, 12 and 5. Number 26, 5 and 13. Yeah, that's it. Now let's check up to here. Check once more. Number 1, 1 and 2. Number 2, 2 and 3. Number 3, number 3, 4 and 5. Number 4, 5 and 6. Number 5, 1 and 7. Number 6, 7 and 8. Number 7, 8 and 9. Number 8, 9 and 10. Number 9, 10 and 11. Number 10, 11 and 12. Number 11, 12, 13. Number 12, 13, 6. Number 13, 7 and 2. Number 14, 2 and 8. Number 15, 8 and 3. Number 16, 3 and 14. Number 17, 8 and 14. Number 18, 9 and 14. Number 19, 14 and 10. Number 20, 10 and 15. Number 21, 11 and 15. Number 22, 15 and 12. Number 23, 15 and 4. Number 24, 12 and 4. 25 is 12 and 5. 26 is 5 and 30. Okay, this is okay. Let's check again the joint coordinates. Joint 1, 0, 0. Joint 2, 5, 0. 10, 0. 22, 0. 27, 0. 32, 0. Okay. Then 7, 4, 2. 8, 8, 4. 9, 12, 6. 10, 16, 8. 11, 26, 12, 24, 4, 13, 28. Just 13. 28, 2, 14, 13, 4, 15, 19, 4. Okay, I think now these are okay. Now rest should be not so difficult, right? Now we are going to run the same. So geometric degrees degrees of freedom we will give in the same way. So for member number 1, we will have 1, 2, 3, 4, right? Then and so on for member 2, member 3, and so on. So let's jump through that. So this is member 1 is 1, 2, 3, 4, 3, 4, 5, 6. So we are doing that one. So now direction, cosines, and lengths. So we can, this is also again in the usual way. Only thing is we need to fix the E is in megapascal. A is in millimeters square. So we take for one member and just write E is 70,000 megapascal and area is 10,000 millimeters square. Then this one will just repeat that. The unit, how many members we have, number of members, and rows is, columns is same. Okay. So now you have your member properties. Then now your local stiffness matrices, nothing will change. You need to convert the length to mm. So you need to multiply by 1000 to convert to millimeter. Then you got your global stiffness matrices, then transformations. So all that will take place here. Then you will assemble your global stiffness matrix. So till there, everything should be same. So, So we have run up to K global, right? So how many degrees of freedom we have? We have 15 joints, so 30 by 30, right? So that is our global stiffness matrix. Okay. So of course it will be not even possible to do by hand. So we are not going to even do by hand. Now let's come back here and we need to mark out which ones of the degrees of freedom are non-zero, right? So again, it is just size is larger, but principle is still same. So we will put a table. Okay. Um, yes. Yeah. Uh, let's do one thing. Let's increase. Okay. So it's enough. So now Okay, so this is the U. So we will put here U1, U2, U3, U4, 5, U6, U7, U8, U9, U10, U11, U12, U13, U14, U15, U16, U17, U18, U19, U20, U21, U22, 23, 24, U25, U26, U27, U28, U29, U30. Right? Now, now you mark here which ones are zero. So for 3 is 5, 6, right? So U5, U6 are 0 because that is fixed. So U5, U6 are 0. 4 is fixed. U7, U8 are 0. Okay. Then nothing else is fixed, right? So only those. Now now for your forces, let's put the matrix of external forces. One, okay. Now so F1 is nothing, F2 is negative 45. And 0, negative 45. Then you have 14. F14 is negative 90. F14 is negative 90. Then F16 is negative 90. 16 is negative 90. Then F18 is negative 90. Then F20 is negative 90. Then F22 is negative 90. Then F24 is negative 90. Then F26 is negative 90. Then F12 is negative 45. So totally we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 forces. So we put on 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that should be right. Then F, we don't know the reactions on those, so we don't know F5, F6, F7, F8. So F5, F6, F7, F8, we don't know. And the rest are zeros. Okay, now we will partition the matrix. So 1 to 4 and 9 to 30. The rest are not there, right? So 1 to 4. Uh, 9 to 30. Okay. So F is, so we will copy that now. Zero, negative 45, 0, 0, and so F5, F6, F7, F8 are unknown. Then 0, 0, 0, negative 45, 0, negative 90, 0, negative 90, 0, negative 90, 0, negative 90, 0, negative 90. So 1, 2, 3, 4, 5, 6, 7 of negative 90. 1, 2, 5, 6, 7. And then 1, 2, 3, 4, 4. Let's check. 0, negative 45. And then 1, 2, 5 zeros. And then negative 45, 0. And then this one, 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. And then 0, 0. Okay, so this is okay. So let's run till displacement. Let's see, K partition size 26 by 26. Let's see. Oh, I didn't put the. Okay. Okay, so now you see you got the displacements. Oh, sorry. So we should, all the forces are should be in Newton. So by 1000. You remember those forces in the question. These are in kilonewton. So we just converted them to Newton. Times 1000. Let's run again. Okay. Okay. So let's just do F equal F2. So that should be fine. So displacements, yeah, those are in. Let's look a bit off. Let me see, Newton, millimeter. Let's check one matrix EA by L of 70,000 times A is 10,000, length is 5,000. 140,000. Let's check. No, this is element 1. 140,000. That is correct. And let me check. Element 5. Length is 2 root 5. Okay. Okay. Oh, okay. So that's okay. That should be fine. Uh, oh, F is in kilonewton. Um, just a minute. Mm, mm, So E 70,000 megapascal, 10,000 millimeter square, or EA by L. L is right. And forces are, yeah, forces are okay. So displacement should come out in millimeter. Okay, so that is correct. Those are okay. Now total displacement is, so which ones were total displacements? Now only these were zero, right? So we need to fit in between number 4 and 5. We need to fit in 4 zeros. So total displacement will be, total displacement is displacement 1 to 4, and then we need to fit in uh, 1, 2, 3, 4 zeros, then displacement of 5 to 26, right? Because we need to squeeze in these. Right now we got all the unknown displacements. From 5 to 9 we need to squeeze in those. So then we can do forces is K global times total displacement. Okay. Now we can remove the I forgot where you remove all the, yeah, clear all breakpoints. Okay. Now you got your forces. So those are your forces in uh, Those are your forces in Newton. So let's just do forces, this forces by 1000. So now you got your forces. Okay. So let's check now. We can just quickly check our reactions, and that should be enough for exam. Like I said, uh, by hand check, we can do a bit later because I need to run somewhere. But what should be the reaction at? So we have 1, 2, 3, 4, 5, 6, 9, no, 7, 90 kilonewton forces. So 90 times 7 and 45 times 2. So total is 720. So we should have 360 kilonewton at 3 and at 4. Let's check that. So at 3, so we have 360. And at 4, 4 means 8. We have 360. Okay. So those two are matching. So the rest should be also matching. You can check member forces by hand. Okay. So let me do one thing, Amira. I will send you this 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 problem one, this MATLAB folder. Let me unzip. Let me zip it again. Okay. So it's sent to zip. Let me send to everybody. Let me zip again, just in case. Okay. Amira, uh, I need to go somewhere now. Bryson, I need to go somewhere, but uh, uh, I will come back on Zoom. Okay. While driving, I might need to join another Zoom, but I will come back on the Zoom. Okay. I'll try to be there as long as possible on the Zoom. Okay. I will be back on the Zoom. Okay, meeting, I'm just leaving. I'm not ending the meeting. Okay, stop share and let me stop recording.